Hello. In this lesson, let's cover some example problems related to the first law of thermodynamics. Alright, so for problem number 1, suppose a woman does 500 joules of work and 9,500 joules of heat transfer occurs into the environment in the process. So what is the decrease in her internal energy, assuming no change in temperature or consumption of food? That is, there's no other energy transfer, okay? And also, what is her efficiency? Well, so if a woman does 500 joules of work, it's a positive work done from the woman to the environment. And also, if he transfers 9,500 joules, so it's heat transferred from the system to the outside, so it's negative heat transfer. We can then just apply the first law of thermodynamics. We know that the variation in the internal energy is the heat transferred minus the work. In this case here, we have a variation of internal energy of negative 10,000 joules. To calculate the efficiency, we know that the efficiency is the work divided by the heat transfer. In this case here, 500 divided by 9,500, and it gives us 5.26% of efficiency. Okay, let's go through problem number 2 now. We have a hand-driven tire pump that has a piston with a 2.5 centimeter diameter and a maximum stroke of 30 centimeters. So how much work do you do in one stroke if the average gauge pressure is 2.5 times 10 to the 5th newtons per meter squared? So this is our pump here. We have a cylinder and with a 2.5 centimeter diameter and 30 centimeters stroke, maximum stroke. Okay. We can just remember that the work can be also calculated by the pressure times the variation in volume. In this case here, we have that the absolute pressure, we want the total work, so the absolute pressure is the gauge pressure plus the atmospheric pressure. Also the variation in volume, if you think about the stroke here, the initial volume is the volume of the cylinder, and the final volume is actually 0. So you have that this variation in volume is actually the volume of the cylinder itself, which is pi divided by 4 times the diameter squared times the height of the cylinder. You can just add the values now and find that the work done by you in this hand-driven tire pump is 50.2 joules. Alright, for problem number 3, we have 5 kilograms of steam that undergo an expansion in a piston cylinder system from state 1 to state 2. And during the process, 80 kilojoules of heat is transferred to the steam and 18.5 kilojoules of work is transferred to the steam by a paddle wheel. Alright, let's stop here, take a look into the drawing. So we know that the heat transferred is transferred to our system, from the outside into our system, so it's a positive heat transfer. Also, the work done by the paddle wheel is done by the paddle wheel to our system. In this case, it's a negative work, alright? Okay, we also know the initial and final specific internal energy, and we want to determine the amount of energy transferred by work from the steam to the piston during the process. Let's assume also that the cylinder here and piston has no heat transfer, okay? It's isolated. So you only have work done by the piston here. Well, in this case, let's again apply the first law. we can isolate the work here, is the thing that we want to find, and also the work, the total work in the system is the piston work plus the paddle wheel work. Also, the variation in internal energy is the mass times the variation of the specific internal energy. Well, we can just isolate the work done by the piston here, done by the steam on the piston here, and add all the values. In this case, we have a work in the piston of 350 kilojoules.
We hope you like this video. Press subscribe, thumbs up, and stay geekly.